Okay, everyone. So, yeah, like I said, I'm going to talk about Shared App Gateway. So, what's the aim for today? We're going to do some fairly basic things. We're going to add an app, we're going to remove an app, and we're going to make sure that when we've got an existing application gateway that we can run a Terraform plan against it and not have any infrastructure drift. So nothing too ambitious, you might think. So where does the problem come from, and what's the context? Well, when you've got a shared application gateway, or the reason for having a shared application gateway is often for cost optimization, and you might want to put multiple applications inside it. And when you go through this process of adding and removing applications, you run into this problem. And it's documented on the HashiCorp webpage. Basically, the various properties of an application gateway are architecturally stored as lists within the gateway. So the various backend settings, the HTTP listeners, the SSL certificates, the front-end ports, they're all basically distilled down to a common set of lists. And the problem is when you're adding and removing an individual application, you get a lot of plan noise because you see a lot of things being added and a lot of things being removed. Makes it difficult to figure out actually what is going to happen. What is the purpose of the change that you're going to make? So why is that? It's an architectural limitation of application gateway. And as a spoiler, no, I haven't rewritten that gateway. So what I've done doesn't fundamentally change that. But what we are looking to do is to improve the noise. So just to illustrate the issue, if you've got multiple applications inside App Gateway, so App 1 and App 2, they get distilled down to a common set of lists, as you see, shared between all the various applications. So the solution, and this is a little bit techie, so I will go into the detail as we get into the demo, but just to set the context, it's a combination of changes to the AzAPI provider, which is the alternative that some of you might know to Azure RM, and work that's going on in Azure Verified Modules. So on the AzAPI side, there's this new list management property. There's a couple actually, but the one that's relevant is list unique ID property. And what that basically does is it allows you to inject a key into a list, which fixes the list ordering problem. So when the list gets returned from the API, it's basically a unordered list. And this property basically allows you to nominate a property within that list to say, hey, that's the key. Basically turns it into like a map or a dictionary, which then makes the it makes it order insensitive, which means you can add and remove things and get a nice clean plan. So what does that mean? That sounds like pretty scary stuff. From a consumer perspective, it actually doesn't really matter because you're just consuming the AVM, assuming this gets landed as proposed. From a module author perspective, as we move over to AzAPI, there are some sharper edges with AzAPI that you need to be aware of. List handling is something that you kind of get as an extra fix, but there's some other areas that we'll talk about a little more later. But the end result is a reliable Terraform plan. So that's part one. Part two of the problem is, okay, so then you've got this way of being able to add and remove applications, but now you need a mechanism to be able to do so without potentially trampling over your existing config. So one way you could approach this is you could chuck all the various apps inside your TFRs, and then when you want to make a change, you're basically editing a shared config. It works. It's an okay starting point. But what if you could do something different? What if you could actually have it so that each application had its own file? You could drop and add an individual file, remove it, and then you'd be clear exactly which thing you're working with. And it also would mean that the configuration is a lot shorter because then you've only got the single application in each file rather than a very long configuration. So how could you do that? Well, one way to do it is YAML. And again, I'll show this in the demo. So what we're going to do is we're going to add and remove an individual YAML file from the traditional place where the TFRs goes. And then you'll see on the right-hand side, it looks very much like what you'd expect to supply an application gateway. So you can drop and add, remove these. And yeah, and if everything works well, then you should just see the changes that you expect. And Mona is going to hopefully watch over us all and make sure that is the case. So that's enough slides. Let's switch straight into the demo. So, boom. Let me just get rid of the stuff on the left so it's a little bit more space so you can see the thing. So on the left, you'll see the Shared App Gateway. There's a link to that coming a little bit later in the talk, so you can follow along. This is an Iron Python notebook, which is quite cool because it lets you basically able to mix Python and Markdown if you've not seen it before, and then you can run it interactively. So for instance, there's some prerequisites for this particular module where you need to have some resource groups and VNets. You could incorporate that if you wanted to, but then you can run something like this and it'll just basically make sure that those prerequisites exist. So if you've seen notebooks, this will come as no surprise to you. This is standard stuff. So skipping down to the deployment, we've got a dev environment that we're working on. And actually, if I just hop into the right location, should have done that already. Let's just go down there and then we'll go to Application Gateway, make sure I get the right one. And then we'll go inside there and we'll look inside the insights and we'll get this bar over there. So this is our starting point. We've got 4 services sitting behind an Application Gateway. And we could initialize Terraform, but that's boring. Let's not do that, but I did it earlier. And we could do a plan, and just to illustrate what the plan looks like, you should end up with something like this. You get 6 resources that need to be deployed. And yeah, it's the plan. Again, nothing exciting there. You could also do an apply, and then you'd have to wait 8 minutes. So I decided not on that, not such a smart thing to do. So I did that earlier, and that's what you see on the right-hand side at the moment. So it took about just under 7.5 minutes to deploy this application gateway with these various resources. So then the first thing that you want to do is, okay, I've deployed the resource, and this is always a good habit to get into. If you rerun the plan, you should get something back that basically says, hey, everything's cool. So let's just try it. And again, mine is going to watch. So it's gone off the screen. Can't see it, Mona. Let's move it up. Perfect. So that's what we want to see. So there's been no changes to the application. It comes back nice and clean. And sometimes you need to do some work inside the module to make that work. So that's good. All good so far. So now we're going to remove an application. Well, how's that going to work? So let me just switch back to the code for a little bit and show you. So inside the module, let's just tidy this up a little bit. Get rid of some of the noise. Inside the module, there's this environments folder. And as you see before, there's these various YAML files which describe the various things. So we've got the backend there. We've got yet another demo app there kicking around. And what we're going to do is basically remove one of these, and then it's going to basically redeploy the app gateway. And it sometimes does this. It's quite annoying. Let's just do save, whatever. Let's go back in again. So then it reloads properly. Cool. So where did I get to? So we did the idempotency check, and now we're going to remove the application. So you see what that basically is doing is all I'm doing is I'm just moving one of the existing YAML files and calling it .back. So it's no longer there. So now there's 3. So now if you run a plan, mine is going to come back again and watch the plan. Doesn't take very long normally, as long as the demo gods are playing nicely. So here you see, so the API dev, this is the one that we've just removed. You can see the request routing rule's been dropped there. You can see the probe has been dropped, but everything else looks pretty normal. The other 3 applications haven't been touched. So if we was to run this, then it should work, hopefully. Oh, you can also do a little bit of, if you want to, you can do a bit of JQ stuff. So if that's a little bit hard to read, then you can basically, as you know, export a, or you may not know, you can export a Terraform plan as JSON, and then you can do your usual wrangling. So this slightly messy stuff that you see there ends up with a nice little thing down the bottom where you get a list of these are the things being added and these are the things being removed. So again, it's JSON. You can do whatever mangling you want. That's just illustrating the point that you can make it even more readable. So then finally, let's go and cook the bun in the oven and set it going. And again, this is fairly quick normally. An illustrating also that this module is, it's got support for WAF and other bits and pieces in there. I'm just illustrating the basic components just to prove the point. So you see there's one change here. It's already showed that because you've seen the plan already. So after the plan, it should go and do the apply, hopefully. Come on, come on, come on. There it goes. Feeling comfortable, Mona? Yeah? Yeah, I think so. I'm feeling fairly confident. Yeah. And there we go. So apply complete. So if we come over here and refresh the topology, we should see the bottom one disappear. And yada, yada, yada. There you go. So now we've just got 3, and now there's 3. So now adding it back in again is really just as simple as renaming that file from back to the YAML file again. So we can do that, at which point now there's 4. And we could run the plan. Yeah, why not? Let's run the plan. Then you can just see what it looks like when you just add one thing. In fact, it probably would have been more sensible if I just ran the apply, because you just then see the plan at the same time. But never mind, we'll do both. We've got enough time. So. Cool, there it goes. There's the plan. And just while we're reading that, I'm going to kick off the apply as well. So we've got a bit of head start. So because you'd never do that for real, you'd always read the plan properly before you go and just blindly apply something. So don't do that in production, folks. There you see, this is the application just coming back, and it's just the 1+1 thing being added, and all the others are basically untouched. It's nice, fairly easy to read. Plan. And you could do the same JSON mangling that you saw before if you wanted to sort of summarize it even more. And there it goes. So that's the plan reran, and then we should see it start to apply. Yep, so it's done. So if we hit refresh over here, we should see the extra item. There it is. It's just reappeared at the bottom. So that's the application restored. So that's basically illustrating how you can have a shared number of applications sitting behind an application gateway, and you can have nicely reusable plans from Terraform. So let's just dig a little bit into what's going on under the covers. So see how the cookie's made. So if we start with the application gateway, so this is from the perspective of the module consumer. So here you see they are currently upstream on my repo. I've just PR'd them this morning. But as you see, all the various applications basically get landed onto a common set of lists. And there's a bunch of locals mangling, which I'm not going to show, but you're welcome to go have a look, which basically take the various lists from these YAML files and then compress them into a common list of backend pools, a common list of front-end ports, and so forth for each of the items. So this is basically how you can use it. And you saw how it works. You just drop the various YAML files inside there. So what's going on underneath the covers? Let's go look at the modules themselves. So we'll open up, just make sure I get the right one. That is the app gateway. So if we come inside here and see, this is the magic. This list unique item property basically allows you to specify the various properties that you want to manage the lists over. So in this case, we're saying, hey, for the front end IP configurations, use the name as the key. And most of the time you would use the name because the name is the thing that makes something unique, but you don't have to. So in the example of the backend addresses, there isn't a name property. So in that case, you can use IP address. And you can also use a common separated list of things as well. So if it's more than one property in this case, then you can have multiple. It's basically you need to find some form of uniqueness that identifies individual items in the list. Cool. So I think that's everything I was going to show here. So let me just go back to the deck. Yeah, that looks good. Let's move on. So I talked about AzAPI. And so what's happening here, for those of you who are not aware, there was an announcement back in December from the AVM on an AVM community call. Basically, Microsoft have signaled intent that they're going to mandate AzAPI for all resource modules in AVM. And it's also preferred for pattern modules as well. So from a consumer perspective, as you see, it doesn't really make any difference. You're just calling a module. How it's implemented under the hood doesn't change. You're still passing the similar things. So why is Microsoft doing this, or why does it make sense? A number of reasons. Firstly, the provider is now much more mature and robust. It's come along in leaps and bounds over the last few years and is now a production-ready replacement. Another key reason is the resources that you deploy are available day zero. So in the Azure RM equivalent, you see there's quite a deep stack here. You've got the API, then you've got HashiCorp's version of the Go SDK, and then you've got HashiCorp's Azure RM provider. And when new features come out in Azure, there's a time delay for them to be added into the Azure RM provider because they're crafted, basically lovingly crafted for each individual resource. So there's a human basically in the loop basically doing this stuff, which means they're able to put a lot more smarts into the provider. The downside is that you often wait in weeks, years, months, sometimes even years for a property or a feature to turn up. So the AzAPI stack simplifies it. It's a much thinner layer over the ARM API, which means you get day one capability and feature parity and consistency with Bicep. The other benefit from Microsoft's perspective is that they own the entire stack. So from the REST API through to the provider, it's Microsoft owned, not HashiCorp owned, through to the AVM module, it's a thinner stack. So that's part of the reasons why. What does it mean from a consumer perspective for this change? There's a number of properties that will change for all resources. One of them, you may be used to using resource group name as a parameter into a module. AzAPI prefers parent ID because it is agnostic to the subscription which is being deployed into. So you don't have that. If you do have a multi-subscription deployment, you don't have to do any kind of magic stuff to aliases and so forth to target the different subscriptions. You can just pass in the parent ID, and that also provides sort of consistency of how Bicep does it as well. If you're a module author, just a hint, tip there, don't try and do anything clever in terms of inferring the subscription ID. Using data sources within modules is not a good idea. The quote from Matt White, data sources are evil. There's a YouTube video at the bottom which explains why. Another common pitfall that people fall into, don't try and infer the location. Same reason, you get known before apply issues. Pass it in as a parameter, keep it simple, don't try and infer it. So, and you'll find as a module consumer, as things move to AzAPI, there's sort of a standardization between Terraform and Bicep. So some variables will change, some resource names will change, and there'll be some upgrade guidance when that happens to help you do that smoothly. From an authoring perspective, a little bit more. So we're not going to go too much detail here, but just to give you a taster, when you want to output things from a AzAPI module, then you specify them as part of the response export values property block. And the advice there is keep that as lean as possible and just put computed values in there. Don't put everything in there, because then you get change potentially coming from that through the inputs basically end up surfacing through the outputs. So keep it lean, keep it to computed values only. Another challenge with AzAPI is it doesn't always know, unlike Azure RM, which is lovingly crafted, it doesn't know when a property will cause a resource to be recreated. So with the exception of name. So it knows that when the name changes, that means the resource needs to be redeployed. An example of that, public IP addresses. If the zone changes on a public IP address, then that means the resource needs to be redeployed. That has to be specified explicitly within the module for the public IP address resource for AzAPI to do that in a way which surfaces up to the module consumer. One of the plus points, a huge plus point in my opinion, of AzAPI is retry, proper retry. So if you've ever had problems with Terraform and you've had to sort of sleep for a resource to be created, this retry capability is a much more deterministic way of doing it. It allows you to look for the specific error, and then it will do exponential back off, and it will keep trying. And if the error isn't there, then, and if it can just continue on and do it, then it will do so. So that means you don't get these non-deterministic issues where you have to kind of guess, how long should I wait for? Sometimes you end up waiting too long, it just makes deployment slower, and sometimes you don't wait long enough and then it doesn't work. So retry is a huge win for AzAPI. And list properties is the new thing that I've just been illustrating, which is a little bit niche and was actually added to fix a problem with diagnostics. It just happens to help with the App Gateway story. So summarizing the stack and where I see the direction and the best way to think about this. AzAPI is the new modern way of writing Azure resources. It is a thin layer, it gives you day one support, it gives you advanced capabilities, but it's a little bit sharper around the edges. So as a module author, you need to do a little bit more work to make sure that from the consumer perspective, you're offering them a good quality experience. That's where AVM, I believe, will step in and help. So I call that taming the line. It basically provides a community-driven standard to help engineer and wrap up those capabilities and smooth that surface and help smooth the gap between consumer and provider. And finally, of course, it doesn't really matter whether you use Azure OM or AzAPI in a module. When it comes to the perspective of a consumer, it's just a module call. So as illustrated with the Shared App Gateway, and for your solutions also. And with that, that's everything. So just sharing the outputs. So there's a PR proposed upstream for both the application gateway module and the associated WAF module. You can see the links there. There is a shared app gateway, which I've just made public just a few seconds ago. So if you scan that QR code, you'll be able to get to that. And finally, thank you very much. And
yeah, thanks so much, mate. That is brilliant and really, really good. I was going to ask you how do people reach you out, but you've already done that, so that is brilliant. People could just scan that. So 2 questions. First one is like if someone wants, what is your advice for someone just wanting to contribute to AVM? So like what is the paved path, or like what is the best what to do if you want to contribute to AVM? And the other quick question, I think all of this is on your GitHub repo, right? If someone wants to go and dig through the details you shared, so that's on your repo.
Yeah, totally. So in answer to the first question, if you go to aka.ms/AVM, that'll take you to the AVM landing page. And if you have a hunt on there, you'll find the contributing section. And there's guides for both Terraform and Bicep contributions. They'll walk you through the process of how you to set up your machine and what the expectations are in terms of testing. And very cool guidance and worth a read, because it shows the testing framework that sits behind the modules as well.
Nice. Love it. Thank you so much, Stu. That is brilliant. Always fun to have you. And yeah, really appreciate your time and your sharing your knowledge. Cheers, mate. And God, Demo Gods was on your site today.
Definitely, so yes. Good. You see, it worked to bring Mona. Yeah,
exactly. Exactly. This worked. Cheers, mate.